Okay, so like I said, I don't have a lot of new material for you. It's more of the same, really. Remember, I keep saying it, the better you are with your vocabulary from chapter 1, the easier this is. I'm going to bring back, we've already brought back some of the vocab from chapter 1. I'm going to bring back some more of it for you today. Clearly, we're writing some more proofs. I know you're happy. So here we go. Here's some more of the chapter 1 stuff. Measure 1 equals 90, measure 2 equals 90, measure 1 equals measure 2. So what is it? What is it called when you have these matching pieces that cancel out? I hear people saying it. What property is that? Transitive. And we can abbreviate. Okay, I'm going to go out of order. I know, just to mess with your minds. I'm going to do it on purpose, though. Let's do 3, because 3 is pretty easy. Now, we saw this yesterday, and we saw it in one of the proofs I wrote with you on the homework. If segment FG is congruent to segment RS, then FG equals RS. Well, of course, if the segments are congruent, they're equal. What definition is that? Definition of congruency. And I just used the congruent symbol. You can too. You're welcome to write it out. It doesn't matter to me. All right, 2. We haven't seen 2 this chapter yet, but we talked about this back in chapter 1. If AB segment, I should say segment AB is perpendicular to BC, then angle ABC is a right angle. That's a definition. Don't all perpendicular lines make right angles? That is the definition of perpendicular lines. I'm just going to say definition of perp. And you can use the symbol for perpendicular too, obviously, if you don't want to write it. So again, everything, it's a free-for-all. You can use anything and everything in chapter 1. So here we go. Let's practice our proof writing. X is the midpoint of PQ, and PX equals AX. Okay, so they filled in the left side. Clearly, we're doing the right side. Now, sometimes, rarely does this happen, but I wanted to do this proof with you to show you that sometimes weird things happen when they do the fill-ins. Meaning, I see they've got the X as the midpoint of PQ given. Now, this bothers me personally. Isn't line 4 part of the given? Why are those not together? That bothers me, but okay. For whatever reason, they separated it. And that's my one complaint sometimes when they have the fill-in, the pre-filled in proofs. I almost rather write this from scratch and put that all in line 1, and I could have done it in 4 steps. But I'll quit complaining now. All right, let's use our vocab. Midpoint. You know it. We've talked about it. What's a midpoint do? Cuts in. Okay, so carefully your segment. It's cutting PQ. X is the midpoint of PQ, so PQ is split in 2 congruent pieces. So that's going to be, you can see the next line. They did PX congruent to XQ. We did that because of the midpoint. Definition of midpoint. Nice and easy. That's not bad because we love our vocabulary in here. Now, we've seen this several times already today. If they're congruent, they're equal. I mean, yeah, okay. But we have to put that in here. What is the reason? Definition of congruency. Now, just to talk about, because I can't help myself, just to talk about why is this definition a congruent statement? Why do we have to have this? Here is the why. Because midpoint makes those halves congruent, but our answer is equal style. If my answer was a congruency, I wouldn't need line 3. I wouldn't have to put it in there. But since our answer is swapped out into the equation style, I have to put that kind of lame stuff in there. That's the reason. Okay, of course given. And now we're to our final answer here. So let's see what we have. PX equals XQ, PX equals AX, and we're down to this. So I see these matching PXs. I'm like, oh, okay. So they canceled them out, and they wrote down what was left. What is that called for like the 100th time when you cancel out those matching pieces and write down what's left? Transitive. Got it. Got it. See? Getting easier, right? Nobody. Okay. Now, one of the things we're going to start using in our proof writing. Now, I'm going to take some pity on you Monday. Get ready on Monday. I'm going to have a list of all the reasons, everything we have used on one lovely handout I'm going to give you in one nice place. This is going to be on it. Right angle congruence theorem. I'm like, well, this makes sense to me. Aren't all right angles congruent? Yeah, because don't they all measure 90? Yeah, okay. So this is something we're going to start using in our proof theorem. Write it. Now, I don't like to write out the whole right angle congruence theorem. I think that's very long and wordy. We can abbreviate it. Or I like to call it RACT, right angle congruency theorem. You're welcome to write the words out or abbreviate. I'm going to abbreviate, of course. So let's do a proof. Let's practice and show why. Because, we're just writing proofs now for a long time. So fill in our given. 1 and angle 2 are right angles. Ooh, I might fit it in one line. Look at me go there. My handwriting's getting smaller. Okay. Now, here's the thing. They want you to prove the right angle congruence theorem, so I cannot use it right now. Okay, all right, fine. Well, I know if they're right angles, I know you know this. If they're right angles, how many degrees do they measure? 9. Okay, so I'm going to say measure angle 1 equals 90, and the measure angle 2 equals 90. Give a sec to fill that in. Now, what prompted me to say those equal 90 from the first line? What key vocab is in our first given line? Or what type of angles? Right angles. So that's our definition of right angles. Angles. Okay, so let's see here where we're going. Okay. Well, I see we have these matching 90s. Okay. So I'm going to cancel out the matching 90s, and I'm going to say the measure of 1 equals the measure of 2. Excuse me. Now, for the 500th time, what property is that when you cancel out the matching pieces and write down what's left? Transitive. Transitive, man, I feel like it's almost in every proof. Okay, eye on the prize. We're almost there, I feel like. If they're equal, aren't they congruent? Yeah. And obviously, they're equal, they're congruent. That's that LAMO reason / step, definition of congruency. Got it. See, easy peasy, easy peasy. Hey, let's write another proof, shall we? Why not? All right, so of course, obviously, we're going to start with filling in the given. DB, perpendicular, BC, perpendicular. This is just one of those tedious stuff I'm aware. BC, given. Got it. Okay. Somebody give every second to write, think, love math. That's us. Okay. Now, what jumps out to me in this first line, perpendicular. So right now I'm like, what do I know about perpendicular lines? What do you know about perpendicular lines? They make what? Right angles. So hey, I'm over here. You can see they got the right angles on there. That's what I'm going to put in here. I'm going to say angle B and angle C are right angles. And I put that, or we know that because of perpendicular. So that's our definition of perpendicular. I'm going to use the perpendicular symbol, just a little less for me to write. Now, just like when you solve equations, you can do different steps than I maybe do it, but we all end up with the same answer. It's the same thing here. You've got choices now. If they're right, I could say they're kind of like the last one, they equal 90. I could go through all of this. Or watch this. I'm going to do it in one more step and call it done. If they're right angles, aren't they congruent? Yes. So I'm going to go right to angle B is congruent to angle C. And my reason. All right angles are congruent. It's that right angle congruency theorem. So I'm just went too far. I'm just going to put RACT. right angle congruency theorem. Man, we're crushing it. Okay, I'm going to show you two more theorems you can use in your proof writing. I'm going to be honest with you. These aren't as common as like transitive, definition of right angle, that sort of stuff, but you can use them and we'll take a look at them. So congruent supplements theorem. Yeah, that's a mouthful, okay? So if two angles are supplementary, we're going to talk about what that word means again. Okay, so humor me. Supplements add up to what? Okay. So it says if two angles are supplementary to the same angle, then they are congruent. Now, this is very, I think, wordy and confusing for something that really shouldn't be. 1 and 2 are supplementary, 3 and 2 are supplementary, and 1 and 3 is congruent. Say what now? Okay. So let's say I tell you angle 2 is, I'm going to make it easy, 120. Now, I'm going to tell you 1 and 2 are supplements. So what would angle 1 need to be if 1 and 2 are supplements? 60, because that makes your 180. Now, if I also tell you 2 and 3 are supplements, what does angle 3 have to be? So it's just being like, oh, okay, if they're both supplements to the same angle, these are going to turn out to both be 60. They would both be the same measure. Now, clearly, they're not always 120 and 60. I just made some easy numbers for us. So congruent supplements theorem. Not quite as common, but you can use it. And obviously, on the flip side, congruent complements theorem. If two angles are complementary, it's kind of the same thing, to the same angle, then they are congruent. So this time, instead of adding to 180, they have to add to what? 90. So let's say angle 5, I'm going to make up something easy, 60. Now, let's say 4 and 5 are complementary. What would 4 need to measure? 30 to make your 90. And then 5 and 6 are complements. So what's 6? So clearly 4 and 6 would be the same thing, okay? That's all it is. We don't use them that much, but I just wanted to throw that in there for you. Hey, should we write another proof? Why not? Why not? Okay, so first, man, they didn't even give you like the 2-column layout here. I'm going to draw one in. I'm just going to S&R, stating its reasons. Let's not get any more carried away than that. Let's fill in our given. Here we go. Angle 1 and angle 2. Our supplements. I'm going to have to abbreviate. Yeah. Now, here's the Debbie Downer part of this. I can't use the congruent supplements theorem. If I could, I would be like done in a heartbeat. They want us to prove that actually works. And this is good. We can practice our vocabulary. So right away, I'm like, okay, supplements. We know supplements add to what? So that's my next move. I'm going to say measure 1 plus measure 2 equals 180. And I'm going to say the same thing for 3 and 2. And of course, that's because we had supplements given to us. So that's my definition of supplementary. Got it. Okay. I'm going to scroll this just a little bit. I think I can get rid of that. Okay. Now, what jumps out to me on the purple, what did I say is practically in every proof? Like, ooh, matching 180s. I'm going to cancel those out with the old transitive, and I'm going to write down what's left. So I'm going to have measure 1 plus 2 equals 3 plus 2. And that's transitive. We canceled out those 180s. We're transitive, man. Okay, eye on the prize as always. We want to get to 1's congruent to 3. Okay. So I want to get to just 1 and 3 in there. Oh, okay, so I need to get rid of these angle 2s. Can you get rid of or cancel out the angle 2s? What would cancel them out if I did what to them? What operation? Add, subtract, multiply, or divide? Subtract. If I subtract angle 2 off of each side, bam, they're out. So I'm going to say 1 equals 3. And we did subtraction, property of equality. And man, we're right there. If they're equal, aren't the angles congruent? Yeah. And our final reason for that, I hear you guys whispering it, definition of, got it. We're getting so good. No, yeah. No, yeah. Okay. Again, it is hard when you start, like I recognize that. It will get easier as we keep practicing, I promise. Okay, last two things I have that we're going to use on proofs, you already know them. Linear pair postulate. That is a mouthful. I'm going to call it LPP. So, of course, linear pair. We know what those are. A pair of angles that make a line. And then, of course, if they make a line, they add to 180. It's all stuff we know. That's just what we're going to use when we write our proofs. We're going to call it the linear pair postulate. I've also talked about this. Vertical angle congruency theorem. Whew, that. We can abbreviate that as, okay? Now, vertical angles. We talked about this chapter 1. Here's chapter 1 again. So like angle 2 and 4 are vertical angles. They are congruent, okay? 1 and 3 are vertical angles. They are congruent to each other. So now I kind of alluded to it in chapter 1, if you remember. Now we're formally telling you vertical angles are congruent. So we're going to use that too today. All right, let's do it. Given. I know, we're writing more proofs. You check. 5 and 3 are vertical angles. 5 are okay. All right. They didn't even give me the 2 counts. Gee. Statements. Reasons. Okay. Angle 5 and angle 3 are vertical. And of course, yeah. And you can see I abbreviate a lot too to fit this stuff in. Clearly you can. Now, I think this is going to be a pretty quick, short, sweet, easy proof. We're getting there, okay? So angle 5 and 3 are vertical angles. I feel like there's a typo on here because it's like, this should say 7. I'm like, there's not even a 3 on the picture, right? I'm like, there's going to be a typo here. That should be 7. 7. I'm like, there's not even a 3 in the picture. All right, and we just said, hey, aren't vertical angles, all vertical angles congruent? Okay, we have ourselves, get ready, a 2-step proof. All vertical angles are congruent. That's that vertical angle congruency theorem. I like a 2-step proof. We crush a 2-step proof. All right. Hey, we're going to do something with numbers. I thought I'd give you a break from proof writing for a second. Which equation can be used to solve for x? We don't even have to actually solve the equation. We just have to pick it out. So look at your angles here. Throw back to chapter 1. What type of angles are those that I circled in red? What's your little special name? Linear pair. And we all know linear pairs, a line, they should total up to how many degrees? So pick it out. It's got to be which equation? B. We don't even have to solve it. How great is that? Okay, got it. Find the value of x. Okay, all right, let's take a look at it. Find the value of x. So I'm looking at my angles here, the 3x plus 1, the 48, 148. What type of special angle are those? Vertical angles. All vertical angles are congruent. So I'm just going to set that equal. All right, I'm going to subtract 1 over. We'll be at 147. I use my subtraction property of equality. Can't help myself. Now I'm going to use division property of equality. Divide it, you get 49. Okay. Home stretch. We're going to make it. I got till 9:30. I got 6 minutes. I've got plenty of time. Plenty. Yeah. We just got to fill in a few things. You got it. Okay. So 1, of course, given. Addition property of equality. And then substitution property of equality. Okay, so we have to figure out what they're substituting in where here. So we got kind of a hot mess here. AB plus BC equals BC. So we know BC and CD are equal, so I'm going to replace those. I'm going to substitute that in. Maybe. Because they wanted me to make a substitution. Okay. And I'm looking at all of this, and I'm like, ooh, man, that's a lot of stuff. I need to look at the picture to figure this out. All right, AB, focus, people. AB plus BC. AB plus BC equals AC. Oh, okay, I got it now. Let me look at this one to make sure it's the same thing. CD plus DE equals CE. Got it. What is that when you combine the smaller segments to equal the big segment? Segment addition postulate, SAP. I'm going to move this up just a little bit. Okay. Then, of course, they want us to make another substitution here. Let's take a look. Of course, we have all of this fun-filled stuff. Obviously, like AB, BC is CD. We got the CD, DE is CE. So they're going to be equal to each other. So I'm going to say AC equals CE. We swapped those in. And this is the lame step. If they're equal, hello, aren't they congruent? Definition of congruent. Got it. All right. Do we have time for this very last one? Yeah. Let's do this for the last one. I'm just going to set up the equations. We don't have to do all the boring solving because I know you can do it. Let's start with A. So the angles I circled with the A's in them, what type of angles are they? Vertical. Vertical angles are congruent. I just have to set that equal. Blah, blah, blah. I know you can solve it. I'm just going to, for the sake of time, give you the answer. Okay. Now we have to do the B's. So the angles I circled with B, what type of angles are those? Vertical, which are also congruent. So we would set those equal. For the sake of time, I'm going to give you the answer, 14. Okay. Just because I want to make sure I give you your homework. I know that was fast and furious. I know. I'm full of jokes today. That's it, fast and furious. Nobody catches something they don't like it. Why is it so hot in here?
I know.
Am I the only one that's like dying?
No.
I was like, oh my God. Yeah. I thought it was just I was, getting worked up about proofs. All right, do your very best. Like I said, no new notes on Monday. We're going to pump the brakes Monday and just practice. Obviously, never fear.